Okay, so moving on to part 1 of question C, we're asked to find the real numbers a, b, and c in the following equation. Okay, so I'm going to look at the right hand side, which is a on x plus b on x squared plus c on x minus 1. And I want to write this expression so that it has a common denominator. And so the common denominator is going to be x squared multiplied by x minus 1. And if you just look at it, there's no need to multiply by this x here because this x actually goes into x squared times x minus 1. We only have to multiply by x minus 1 to get this denominator. And so what you do to the bottom, we must do to the top. So a has to be multiplied by x minus 1. So it's ax x minus 1. And we do in a similar fashion x squared to become the common denominator. We have to multiply by x minus 1. And so we do the same for b. So b times x minus 1 is b x minus 1. And x minus 1 to become the denominator, we have to multiply by x squared. And so we multiply c by x squared and we get cx squared. Okay, so relating this equation here, this new, well, it's not really new, it has a common denominator. So relating this new way of writing, new form, with the left hand side, which is 1 on x squared times x minus 1, we find something interesting. So this would equal to ax x minus 1 plus b outside of x minus 1 plus cx squared all over x squared x minus 1. So if the denominators are the same, but the numerators, so the numerators have to be the same. In other words, 1 must equal ax outside of x minus 1 plus b x outside of x minus 1 plus cx squared. Okay, so I'm going to clear the board. Alright, so I've cleared the board and I've moved this equation upwards, so I have more room. If I were to expand this, I would get ax squared minus ax plus bx minus b plus cx squared. And I'm going to group the x squareds together, so I've got ax squared plus cx squared, so that's a group there. The x's together, so bx minus ax, group there, minus b. And if I were to take x squared out, I would get a plus c x squared plus b minus a, and x outside, minus b. And so if that equals to 1, it's easy to see that this must equal to 0 because there's no x squared on the left hand side. This must equal to 0 because there's no x on the left hand side. And minus b must equal to 1. And so if minus b equals to 1, b must equal to negative 1. And if b minus a equals to 0, and b is negative 1, in other words, negative 1 minus a equals to 0, then negative a would be 1, and a would be negative 1 as well. And if a plus c is 0, and a is negative 1, then c must be 1. So our answer is b equals negative 1, a equals to negative 1, and c equals to 1. Okay, so part 2 of question C is asking us to find, in other words, given what we've done in part 1, find the dx. Okay, so we know that this expression can be written as integral of a on x plus b on x squared plus c on x minus 1 dx. And from part 1 we learned that a equals to minus 1, b equals to minus 1, and c is 1. Okay, so substituting these values into this equation here, I can rewrite the integral as minus 1 on x minus 1 on x squared plus 1 on x minus 1. Okay, so that makes it a lot easier now. Taking it bit by bit, so integral of negative 1 on x would be negative ln x. Integral of negative 1 on x squared, and 1 on x squared can be written as x to the power of negative 2. And so if we increase the index by 1, so it's negative 1, and write the negative 1 underneath as well, we get negative 1 x to the power of negative 1 over negative 1 plus the integral of this would be ln x minus 1. That's because whenever we have f, the derivative on top of function, so function on the bottom with a derivative on top, its integral is always ln of the denominator, the ln of the function. So we get that here. And so to rewrite this would become positive 1 on x, and this here can be written as ln x minus 1 minus ln x, and this becomes ln x minus 1 on x plus 1 on x. And it's important not to forget the constants once we integrate the function. So this is our final answer.